We're still on the topic of nomenclature of inorganic compounds. So this time around now, we're looking at those metals which have variable oxidation state, meaning they do not have a fixed charge. So those ones, especially those transitional elements, with the exception of, I think we mentioned, there was cadmium, zinc, and silver. Those were the three elements. Those ones, talk about silver for. Silver is just silver nitrate, silver chloride. Silver has a fixed oxidation state of +1 or charge of +1. So you can see that we changed the words from charge, oxidation state. It is okay. So those ones at the center of the periodic table, I think you've seen them. They have variable oxidation states. So our idea is that we should be able to name them accurately. So examples are that there are two types of ions, which are Fe2+, which is ion 2, and Fe3+, which is ion 3. So even copper, there's copper plus and copper 2+ ions. So naming them, just as say, if you say copper chloride is not sufficient anymore. So that difficulty is resolved in what is called the stock system. So in that system, you use Roman numerals. So immediately after the name of the metal, you put the Roman numeral to show the charge which the ion had, the charge of the ion. So e.g., the Roman numerals, remember, write them like that. 1, 2, 1 is I caps, 2 is double I caps, 3 is triple I in caps. Then for 4 is IV. Then 5 is V, and so on. But it doesn't go beyond 5 necessarily. Yeah, you can have 6, which is VI, but ukusangana 10, it's not possible. So those are the things. That's why even on the examples, you've seen that that's just going as far as 5. So if you have iron chloride, Fe2+, this one is iron 2 chloride. How sure are we? The explanation is here. Because some of you, that's a complaint. Guys, someone kulemba fimbi. Iron 3 chloride, no issue. So, if you look at this one, FeCl2, the example is here. Since you know that chlorine is a halogen, and the charge on the chlorine, on the chloride ion, is -1. So if the oxidation number there is -1, you remember we have to multiply times this 2, which is down there. So 2 times -1 is -2. So if that be -2, because we know that the sum of oxidation numbers must be 0. So if this is -2, then this is +2. So this is Fe2+. So that's why we are calling that one as iron 2 chloride. The same case, the same explanation here. We know that the chloride ion is -1 times this 3. It means the total charge for the chlorines is -3. So if that's -3, to cancel out -3, you need +3. So that's the reason why you get it. This one as Fe3+. So even when you're just given this formula, you should have that skill of reading it as iron 3 chloride, iron 2 chloride. Then this one is -1. It means this one is +1. So this is copper 1 chloride. The copper is Cu plus. Then this one is Cu, Cl2. You know this is -1 times 2, -2. Then it means this one is +2. Why is this one +2? Because when you add the charges, the total oxidation states or the charges in a compound, the sum must be equal to 0. So the explanation is set there to say if you have chlorine, since you have -1 here for the chloride, and there are 3 of them, 3 times -1 is -3. It means this one is +3. So those are the things. So this only applies to the transitional elements, meaning for calcium, taufile waba 2 overwhelmed nga omasana ma iron 2, copper 2, tukom for wasalem, but potassium 1, na calcium 2 chloride, tetuagachongeyo. So the rules there are, you write the name of the cation, say ion, then you write the charge in Roman numerals in the parentheses, meaning immediately after. So you put the 2 there in Roman numerals, chloride. That's all. These things are very simple. Huh? These things are very simple. So there is what is called classical nomenclature. Classical nomenclature. You only learn about it because when you go in books, some authors, they still use classical nomenclature. But for our level, our expectation is for you to know the stock system. We want you to master the stock system. But classical nomenclature, so that you don't get lost, to say why does it say ferrous chloride? So this one, for this, there's a lower charge. In the case of those that only have 2 oxidation states on the periodic table, there's a lower charge and a higher charge. This one is the classical nomenclature is so unique that for tin you find it says stannous, stannic. Those are the things that appear there. So you discover that for some metals, even the names that are used are the same old names in the periodic table that they had for their charge. Because if you've seen, iron is Fe from ferrous. Copper is cupric, Cu. So those things, the classical nomenclature uses the actual old names from the discovery. So the IOS and IC. The IOS features when you are dealing with a lower charge, e.g., if you have Fe, we've said that we only have 2 types of ion. There's ion 2 and ion 3. I'm sure you know that. So the ion 2 is lower. So the lower one ends with the OUS. So the lower one, which is ion 2 chloride, is called ferrous chloride. The higher charge, which is ion 3, is called ferric chloride. So there are only 2 names there. Ferrous, Rus, for lower charge, ric for higher charge. Chimona padi copper 1 and copper 2. We only have 2 types of copper. So the first one, the copper one, is called cuprous chloride. Cuprous chloride. The higher charge, which is copper 2, is the one which is called cupric chloride. This one is just nice and fancy. You find in a book, ferrous chloride reacts with this. bavika pona equation tawufira wambo kutalika we tefu twasambirira maro yali kuisa no. That's not how it should be. You guys are sharp. You're clever, I know. So now I gave you work there. I'm sure some of you have been tackled and attempted. Let me check if some people have attempted. Lead to chloride. This is okay. Tin for fluoride. Richard, very good work. Then Richard Kaipalamana. Then iron 3 oxide. Nademba Fegweno. And copper 2 oxide. This is copper 2 Tatawanan by Richard. So Richard, you have messed up one. It's copper 2. Why is it copper 2? You know that the oxidation state here is -2 for oxygen. So it means this one is definitely +2. Maimva Tatawa Richard. Such that ngawakwata ka2 hapa, which is not the case for copper. Ngawakwata ka2 hapa, you multiply 2 times -2 equal to -4. It will be copper 4. Although there's no copper 4 in practical use. So this is encouraging, Richard. You've only messed up one. Which is CuO. But from what I can see Cu2O. Cu2O is the one which is copper 1. So that is the case for these. So let's have not quaterferrous. So this is copper 2 oxide, iron 3 oxide. Why iron 3? You work out the same thing. 2 times iron, you look for the oxidation state. 2 times iron, then a power 3 times -2, which is -6 equals 0. So when the 6 goes there, we divide over 2. It means the iron is 3. So that's the case. For fluorine, it's -1 and iodine is -1. So you just multiply -1 times 4, you get -4, meaning the other one is opposite, it's +4. So that's why you have tin for fluoride. Then lead to iodide. Then apart of some kulembama formulas, chromate, it's on the polyanions. That's why you have chromate. Tin 2 fluoride, you can work this one out. Kuchinja fama charges. So go and send the charges, you work these things out. So the chromate ion, nimfi bikapo, opofidi fama charges, if you are person. So for the chromate is CrO4 2-. Then now kwatana ion yoboku. So you write the ions, then you exchange the charges. Remember that if you have a polyanion, you treat it as a single entity. Chromium bromide, chromium namu ikwata Cr3+, bromine Br- wafichinjafi. So apawala lemba, tin is SN4+, then you lemba na Cr4 2-, ngafya chinjanya, it will just be SN, then you open brackets huko. Ubika mo CrO4, then you close the bracket na 2 panze mshwaria. Copper 1 oxide area 2 apa copper 1 nabika po Cu+, Cu+, then O bika po 2-. Ngafya chinja na charges, it will be Cu2O mshwakwata copper 1. Tin fluoride is SN, tin 2 fluoride is SnF2. You only know these and perfect them by practicing. Then this one is when you have anions. always, except for organic compounds where there is so much. These are inorganic. Let's note that these are inorganic. So roughly, the only one whose place is not very certain is the hydrogen. The only one whose place is not certain is hydrogen. Sometimes you can start asking, what of ammonia? What of ammonia? What of the organic substances? So nitrogen has a limited space here, but this table is for electropositivity. This table is for electropositivity, guys, meaning the most electropositive is silicon. So this one, in a formula for an organic compound, silicon is named first before everything else. That's why even between oxygen and fluorine, the OF2, you start writing the O first. So that's how it is. If you want to write anything, calcium dioxide, this is an electropositivity series like of sorts, where we are just affirming that silicon is more electropositive than all of this, and fluorine is the most electropositive of all of them. So you write the most electropositive first, then the electronegative next. The only exceptions are hydrogen and oxygen. But just hydrogen is the exception there. The rest, you write them likewise. Just hydrogen is the what. So here na nakasana because you only use these prefixes, the Greek and Latin prefixes, which are mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta 7, octa 8, nona 9, deca 10. So these ones, the only thing to note is that mono, taibomba guys, mono. It's rarely used mono. The prefix mono is rarely used for naming the first element. It's rare to say monohydrogen, mononitrogen, monoshan. But if you write that your own, we can accept. Only should ever examined. You cannot be penalized. But it's rare that you write mono. In fact, for the first element, almost always omit it. So those are things. Then if someone just says nitrogen oxide, the first assumption is that now drop off mono ponsapabili. Someone would think what you mean is actually mononitrogen monoxide or nitrogen monoxide. So those are things. More than one. So those are things for our prefixes. So the example is here. There are 2 nitrogen N2 O3. 2 nitrogens, 3 oxygens. So 2 is di. So you say dinitrogen trioxide. Dinitrogen trioxide. There is a limitation, guys. Padi mono, ngakuli oxide. Mono. Remember mono, then na oxide, kama O yaba double panya. We drop out one O there. We just write monoxide. So that's the thing. Even penta, the A is dropped for penta. Instead of saying pentaoxide, we say pentoxide. I'm sure you will see it somewhere. Pentoxide. Do you have penta? Is tapadiapa or poidap? We just say pentoxide instead of saying pentaoxide. Diphosphorus pentoxide. Carbon dioxide. Phosphorus trichloride. Sulfur dioxide. Carbon tetrachloride. Carbon monoxide. Dinitrogen monoxide. Dinitrogen tetroxide. Nitrogen monoxide, dinitrogen trioxide, disulfur dichloride, disulfur decachloride. tapati fyakwati mulanda chano sanshufikisha po kupenda ngayadi yabiri apapadiimo, so it's just nitrogen followed by one oxygen, so nitrogen monoxide. Then ayadi ayadi po sulfur S2 CO2, so sulfur is 2, so you said disulfur, then dichloride. So those are the things. I'm sure you tried out to name like this one, phosphorus pentachloride. Who can give me the name of the first one up? The first practice. CO2O. Naisosha sana. Everton. CO2O.
Dichloride oxide.
Daishan.
What's that?
No, I'm asking you because I want you to know this thing.
Dichloride monoxide.
Guys, chloride disangwa pari next name. Who is this person who has raised the hand?
Dichloride.
Richard.
So,
yeah.
It's a trichlorine oxide.
Dichlorine monoxide.
Monoxide.
Dichlorine. The chloride thing, chloride, IDE, is only modified for the second name, for the second substance there. Mayumvate? Takwabo kwamba na IDE pa first. So the first one, like chlorine, kuita as chlorine. So you should just say dichlorine monoxide. Are you getting? The IDE is on the oxide. But the chlorine, since in the first name, you don't modify it to end with IDE. Are you getting it? Even this one, what the next one is what?
Sulfur dioxide.
Sulfur dioxide.
Sulfur dioxide.
Yes, sulfur dioxide. This one is just ammonia. Don't waste so much time. Although ammonia should have been called nitrogen trihydride. But we don't call it that. We just call it what? Ammonia. But it should be nitrogen trihydride. So those are the names. So you just perfect. N2O5. N2O5. Yes.
Dinitrogen
pentoxide.
Chongo, you are the one answering.
Dinitrogen pentoxide.
I wanted to say that it's dinitrogen pentoxide.
Dinitrogen pentoxide. Dinitrogen pentoxide. So, guys, you just have to improve this aspect of nomenclature. You just have to improve or perfect. This thing is mixed, but this one now is a mixture of everything. If you're able to name all of these correctly, I add practice 4. Nomenclature wakwata kufanya ideas because the first two are fixed oxidation state. The next two, the next one is sulfur. Now F, these ones are non-metals. Then tin, na copper, these ones are variable oxidation states. These are transitional elements. So just go and practice, guys. Remember takwa potassium 1 bromide takwa bayo. Na calcium 2 nitrate takwa or nitrite takwa. So start to analyze them like that. There's nothing like calcium 2 nitride. Remember again, the mistake Kanaka Chipangana never did first. We all make it. ukumona kwati nakani mo conserving ngamafe chlorine ni chloride. No. The IDE is only modified for the second name. So the IDE won't suffice when you're naming the oxide. So those are the things. So you go and look at that. The next thing, guys, but if you're not saying is to name, for us to be able to name these things. We're using ilanga mr promise atinkaleta ama polyatomic anions, polyatomic ions, in fact, in this case. So the only one which is positive in this case is ammonia. There's also the hydronium ion, it's also positive. Tukairanda ponga tuenda pama acids, the hydronium ion. So almost all these are negative. You treat them as a single instinct. Or less a name. You write the name of the cation and the name of the polyatomic anion. So meaning if you have sodium Na, ion say acetate. Sodium acetate. You just have to master which out there an ion looks like. So even when you have say KBrO3, you just say potassium bromate. That's how you work these things out. So there was also an explanation on the difference between the ATE and the ITE. I'm sure manufactured nitrate na nitrite. Manufactured na sulfate na sulfite. Na ibomba nama oxygens. These are oxyanions. Oxygen. So the ATE is for equal tamananyayeng. The one that has more oxygens should end with ATE, area video of the type. So like this is sulfate, this is sulfite. Then could nitrogen, nitrate, nitrogen, oxynitrogen, ions. There's NO3, then there's also NO2, minus. So this is nitrate, this is nitrite. So that's the reasoning. The rest, kuko type skill guys inga wayamona fe wayamona fat ini anion na ini anion. Kwadi baba aya ba unique. Liminoku ya chapa tatu wakaacha e.g. mercury 1. Mercury 1 is also a poly. Those are mercury ya ba vidi. Hg2 then 2 plus. So ngole working ingira as an entity. Don't say mudi nan ingira as an entity. So you find you have this one Hg2 then panse power Cl2. So it's mercury 1 chloride. But when you look at it, the mercury, you treat it as a single instant na ikwata 2 up. So these are the things. The rest, 2 more common names, so that you just familiarize. There are these hydrogen sulfates. So those ones, even hydrogen carbonate, this one, hydrogen carbonate, they're also called bicarbonate, biphosphate, bisulfate. So ngamfati bi ni hydrogen something. Those, I'm sure you've seen them before as you go to practice. So these are the things we're expecting of you. So this is simply sodium nitrate. Tafuri watu walomba sodium nitrogen oxide. Bala lembaba ni nufine ndirondo. Sodium nitrogen trioxide. Ana mkulolela mansa ya results. Mshibara chunga ishita shibaka ndolo. So those are the things. One of the unique ones is also the oxalate. Ushopo ilipatebwa pa oxalate. C2 oxalate. I don't think it's there. This one, guys. C2O2, 2 minus. Ilikuisa pala oxalate. So that's the thing. So guys, let's see. Just perfect this. Oxalate, I think I have somewhere. Okay, sodium bioxalate. sodium hydrogen oxalate. C2O4 2 minus isa mukwaluka oxalate. But in remember that H, if there's an hydrogen in front of something with a charge of 2, the charge is reduced by negative. The carbonate is 2 minus, but in bicarbonate, which is HCO3 minus, or hydrogen carbonate, you discover that it becomes just a minus. The rest is here, is a summary of how to name the binary. So if you have two metals, so if you have two metals, you use a prefix daishan. So, but our nomenclature have a few. You have metal and non-metal. If there's a fixed charge, then you just name the metal, and then the other name, the second name is the only one that ends with IDE. Anyone who is inspired to conclude the lesson? Anyone who is inspired to conclude the lesson? Nomenclature is practice, guys. So go and look up the polyions, especially the dichromate. Dichromate. Now the permanganate. Then there's also hydroxide. Then cyanide, carbon and nitrogen. They make their own cyanide. Normal ninja, cyanide salts are heavily poisonous. There's also one mulabuyan, cyanide. But you mune nwasa panga ya vidi. Kachofu watch today, kumanza kura kwene, apanga 2 solutions. Adefano yonse ya vidi. Pakuchafu. Anu inefye imo. Imbi talatula nokutula afwa ni talatula ili achabule imbi. That's how like it's so deadly. Ngawanwafye, you instantaneously die. It's not like arsenate salts, arsenate salts, arsenate salts, mudi arsenic. Arsenate salt na phosphate, they are the only two on our table that have a charge of -3. They are the only two on our table that have a charge of -3. So always master those things. So I was saying arsenic salt also yale fire, but it's not quite cyanide. Arsenic slowly, you are poisoning someone's body. So this year will become a poisoner. Asafa by January. Nshura mutensha, demusonga bona filafine, then ale munana ke abufile ino mpela akushira nechuma. Yali babwino. Cyanide aba umeba bonfi. Kaya ba umeba foku ipaya barapeni. Mbaba nakashija atenda la kuipaya. Ude ondoloka, ude fwa, adese kafe mumbati. Bad ba patient. But men are brutal. So men they use cyanide. Even potassium hydroxide is a powerful poison. Eisumana sana yena kai ngabamkuma autopsy. Taimoneka no kumoneka. Umuntu kufa kwati afile na heart attack. Kai the potassium mumo yabana mu bloodstream. So ila luba. So those are the things. So you need to be knowing these things, guys. So tumuno benga umuna fuata ataki otakwete wa mwamu kupimisha. Nango wewe na umuna folelo alila mmala wachinje fyakuli. No chata alikeni fendi madina juice. So guys, we are almost done. We are done. I would just love to encourage you that this is about practicing. So practice and practice and practice. Enjoy your day and sharp. Taturafika pali test, stop kula tina test, no kula lumbula. We are not yet at the level of a test. You will be ably informed. I promise you. So if you are in a cave, guys, continue to think that these things are simple and continue to practice. It's normal to make mistakes. That's part of learning. So